Welcome to the lesson on the graphical method of solution. At the end of this lesson, you will be able to define the general form of a pair of linear equations in two variables and solve the equations graphically. You will also be able to state the conditions for a pair of linear equations in two variables to have solutions. In everyday life, you will find many things that share a one-to-one relationship with each other. For example, the harder a ball is kicked, the further it will go. Other examples include the quantity and cost of things. 5 balls will cost more than 2 balls. The age and the height. As a baby grows, her height increases. The altitude and the temperature. As you go higher, the temperature decreases. Such relationships are linear in nature and can be expressed mathematically as a pair of equations in two variables. In this lesson, we'll discuss how a pair of linear equations in two variables can be represented and solved graphically. Let's see how. Let's begin by defining the general form of a pair of linear equations in two variables. Consider an example. Mekong wants to know the new taxi tariff. A taxi tariff plan has two components: the fixed minimum fare and the variable fare that is based on the distance covered in kilometers. For a distance of 10 kilometers, he has paid a fare of 115 rupees. And for a distance of 15 kilometers, he has paid a fare of 165 rupees. Let's assume that the fixed minimum fare is X rupees and the variable fare is Y rupees. Here X and Y represent the ordered pair. Based on the given data, the first equation is X plus 10Y is equal to 115. And the second equation is X plus 15Y is equal to 165. These two equations can also be written as follows. Based on these equations, we can write the general form of a pair of linear equations in two variables as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1 and c2 are all real numbers, and a1 square plus b1 square is not equal to 0, and a2 square plus b2 square is not equal to 0. Now, can we represent this pair graphically? Recall that a linear equation in two variables, when plotted on a graph, defines a line. So this means when a pair of linear equations is plotted, two lines are defined. Now, we know that two lines in a plane can intersect each other, be parallel to each other, or coincide with each other. Do these conditions apply to the graphical representation of a pair of linear equations in two variables? Let's plot this pair of equations to understand this. In order to plot the linear equations in two variables, we will have to find at least two ordered pairs for each of the linear equations. Let's consider equation 1. Next, we'll regroup the equation such that y is the subject, or y is on the left-hand side of the equation. Let's call this equation 3. Now, by taking values for x and substituting them in equation 3, we can obtain the corresponding values for y. In this case, we are taking the values of x as -5 and 5. You must be wondering why we have chosen these values. Adding and subtracting 5 will make the numerator divisible by the denominator. So, you will have to do a little bit of analysis before deciding the values you want to substitute. let's substitute -5 for x in the equation and solve it. The value obtained for y is 12. So the first ordered pair is -5, 12. Next, we'll substitute 5 for x and solve the equation. The value obtained for y is 11. Hence, the second ordered pair is 5, 11. The two ordered pairs for equation 1 are -5, 12 and 5, 11. Similarly, the second equation can be rearranged such that y is the subject. This is equation 4. Here the values for x are taken as -15 and 15. Substituting these values for x in the equation and solving it, we get the values of y as 12 and 10 respectively. Therefore, the two ordered pairs for the second equation are -15, 12 and 15, 10. Now, let's plot the ordered pairs for the first equation. We'll get a straight line. Similarly, on plotting the ordered pairs for the second, we get another straight line. As you can see, the two lines intersect each other at 15, 10. This is the solution of the two equations. It implies x is equal to 15 and y is equal to 10. Thus, the fixed component of the fare is 15 rupees and the variable component is 10 rupees. As discussed, when any pair of linear equations in two variables is plotted, two straight lines are obtained. These lines may either intersect each other or be coincident with each other. These lines can also be parallel to each other. Each of these conditions will determine the solution of the equations. Let us look at the first condition where the two lines are intersecting each other. This is possible only if a1 divided by a2 is not equal to b1 divided by b2. Then the pair of linear equations will have a unique solution. Consider the pair of linear equations given here. Here a1 is equal to 2, b1 is equal to 4, a2 is equal to 1, and b2 is equal to -3. On substituting these values in the condition, we get 2 upon 1 is not equal to 4 upon -3. Here the pair of linear equations will have a unique solution. This means that the lines representing these equations intersect only at one point. Next, let's consider the second case where the lines coincide with each other. This condition is possible only if a1 upon a2, b1 upon b2, and c1 upon c2 are equal. In this case, the pair of linear equations will have infinite solutions. Consider the pair of linear equations given here. On substituting the values of a1, a2, b1, b2, c1, c2 in the condition, you get 1 upon 2 is equal to 1 upon 2, which is also equal to 1 upon 2. This pair of linear equations have infinite solutions. A pair of linear equations which has a unique or infinite solutions are said to be consistent pair of linear equations. See, the lines represented by the linear equations are coincident here. A pair of linear equations, when plotted, may define lines that neither intersect nor coincide. These lines are parallel to each other. Such a situation is possible only if a1 upon a2 is equal to b1 upon b2, which is not equal to c1 upon c2. Here the pair of linear equations has no solution. Such a pair of linear equations is said to be inconsistent. Let's look at an example of an inconsistent pair of linear equations. On substituting the values of A1, A2, B1, B2, C1 and C2, you get 1 upon 2 is equal to 1 upon 2, which is not equal to minus 6 upon minus 5. As you can see, these lines are not intersecting. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. Two linear equations in the same two variables are called a pair of linear equations in two variables. The most general form of a pair of linear equations is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0, where a1, a2, b1, b2, c1, c2 are real numbers, such that a1 square plus b1 square is not equal to 0, a2 square plus b2 square is not equal to 0. The graph of a pair of linear equations in two variables is represented by two lines. If the lines intersect at a point, then that point gives the unique solution of the two equations. In this case, the pair of equations is consistent. If the lines coincide, then there are infinitely many solutions, as each point on the line is a solution. In this case, the pair of equations is consistent. If the lines are parallel, then the pair of equations has no solution. In this case, the pair of equations is inconsistent. Welcome to the lesson on algebraic methods of solving a pair of linear equations. At the end of this lesson, you will be able to solve a pair of linear equations using three algebraic methods: the substitution method, the elimination method, and the cross multiplication method. You will also be able to solve a pair of non-linear equations which can be represented as linear equations. You have learned how to find the solutions of a pair of linear equations graphically. However, this method may not always give the most accurate solutions, especially when the point representing the solution has non-integral coordinates like square root 2, square root 3, or 1 divided by 3, minus 5 divided by 4. Identifying such coordinates can be quite a challenge. So, how do we solve such equations? Algebraically, of course. There are three algebraic methods that can be used to solve a pair of linear equations. Now, recall that a pair of linear equations in two variables can either have a unique solution and infinite solutions, or no solution. To verify this, we can compare the ratios of the coefficients of the x and the y variables. Consider the standard form of a pair of linear equations in two variables. If a1 divided by a2 is not equal to b1 divided by b2, then there will be a unique solution. If a1 divided by a2 is equal to b1 divided by b2 is equal to c1 divided by c2, then there will be infinite solutions. If a1 divided by a2 is equal to b1 divided by b2 is not equal to c1 divided by c2, then there will be no solution. Let's begin with the substitution method. Consider the pair of linear equations x minus y is equal to 5 and x plus 2y is equal to 20. The first step to solve a pair of linear equations by the substitution method is to solve one equation for either of the variables. In other words, we can solve for either x or y in either equation 1 or equation 2. The choice of equation or variable in a given pair does not affect the solution for the pair of equations. To keep it simple, choose the equation and variable that can be solved quickly without complication. Looking at these two equations, we can see that rearranging equation 1 to make x as the subject is simpler. So, we solve for x in equation 1. We have x is equal to 5 plus y. In the next step, we'll substitute the resultant value of one variable obtained in the other equation and solve for the other variable. Here we'll substitute the value of x, which is equal to 5 plus y in equation 2. Let's solve this equation further. Hence, the value of y is equal to 5. In the last step, we can substitute the value obtained of the variable in any one equation to find the value of the second variable. So, here we'll substitute the value of y, which is equal to 5 in equation 1. Let's solve this equation. Hence, the value of x is equal to 10. Therefore, the solution to the given pair of linear equations is x is equal to 10 and y is equal to 5. The solution can be verified by substituting the values of x and y in both the equations. Let's check this out. In equations 1 and 2, substituting x is equal to 10 and y is equal to 5. We can see that both the equations are satisfied. Next, we'll learn another algebraic method, the elimination method to solve a pair of linear equations. The elimination method, as the name suggests, involves elimination of one variable by equating the coefficients of that variable in both the equations. Consider the pair of linear equations 5x minus 2y is equal to 14 and 3x plus 5y is equal to 120. In this method, the first step involves multiplying the equations with suitable non-zero constants so that the coefficients of one variable in both equations become equal. Here we'll multiply the first equation by 5 and the second equation by minus 2. By doing this, the coefficients of y in both the equations becomes minus 10. Please note that minus 2 and 5 are the coefficients of y in equation 1 and 2 respectively. The next step is to subtract one equation from another to eliminate the variable with equal coefficients. In this case, we'll subtract. So, we now subtract the fourth equation from the third equation. This eliminates the variable y and leaves the equation with just one variable. Now we solve the equation to get the value of the remaining variable, that is, x. Solving, we get x is equal to 10. The next step is to substitute the obtained value of the variable in one of the equations and solve for the second variable y. Substituting x is equal to 10 in equation 1 and solving, we get y is equal to 18. Therefore, the solution to the given pair of linear equations is x is equal to 10 and y is equal to 18. Let us verify the solution by substituting the values of x and y in both the equations. Substituting x is equal to 10 and y is equal to 18 in equations 1 and 2. We see that both the equations are true. In this pair of linear equations, we have obtained a unique solution for the pair of equations. We will now discuss the third method of solving a pair of linear equations, the cross-multiplication method. Let's consider the general form of a pair of linear equations. a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Recall that when a1 divided by a2 is not equal to b1 divided by b2, the pair of linear equations will have a unique solution. To solve this pair of equations for x and y using cross-multiplication, we'll arrange the variables x and y and their coefficients a1, a2, b1 and b2 and the constants c1 and c2 as shown on the screen. Now, we write x divided by the product of b1 and c2 minus the product of b2 and c1. Following the same procedure for y and 1 and equating the three fractions, we get the expression as shown here. Now, let us try this method on equations we have earlier solved using the elimination method. Let's rewrite the equations in standard form. Now, let's compare the ratio of the coefficients of x and y. It is not equal, which implies that the equations have a unique solution. Now, let us apply the cross-multiplication method and solve the equations. We get x is equal to 10 and y is equal to 18. The solution obtained is the same as the solution obtained by using elimination method. we can use any of these three methods to solve a pair of linear equations. However, the trick is to use the method that is simple and convenient. Consider this pair of equations. These equations are not linear. So, how do we solve such equations? Equations like these can be reduced to linear equations. Let's see how. First, we'll rewrite the equations as shown. Next, we'll substitute the fraction 1 divided by x plus 2 with u and the fraction 1 divided by y minus 2 with v respectively. So the two variables in the pair of linear equations are u and v. Now, using any of the three methods, we can solve for u and v in this pair of linear equations. Let's use the elimination method. Observe that the coefficients of v in both the equations are same. So we can eliminate v by subtracting equation 4 from equation 3. Simplifying, we get u is equal to 1 divided by 7. Now substituting the value of u in equation 4 and solving. We get v is equal to 1. We know 1 divided by x plus 2 is equal to u, and 1 divided by y minus 2 is equal to v. Now we substitute the values of u and v in 1 divided by x plus 2 and 1 divided by y minus 2 and solve for x and y. Therefore we get x is equal to 5 and y is equal to 3. Let's substitute x is equal to 5 and y is equal to 3 in equations 1 and 2. Next, we'll simplify the equations. As you can see, the linear equations are satisfied. Thus we have verified. So, we can solve for any pair of nonlinear equations if such equations can be represented as a pair of linear equations.